Today the subject is phototherapy. Phototherapy. Therapy means treatment. Photo here it indicates light. So the treatment using light. This has been in practice since 1958. It was actually discovered by one nurse and a doctor in the hospital, the Rockford Hospital in England. It was a serendipity actually, it was by chance, because this nurse noticed that the yellow color of the baby is subsiding when this baby was taken outside under the sun. So it was actually the sun rays which has helped to decline this jaundice. Here first you have to see what is jaundice. Jaundice is a term used to indicate the yellow color under the skin due to the accumulation of a particular molecule called bilirubin. Bilirubin. Where is this bilirubin coming from? There we have to go to the erythrocytes. Let this be an erythrocyte. When this erythrocyte is destroyed due to various reasons, what will come out from this erythrocyte or RBC? The hemoglobin which is inside this RBC will come out. Hemoglobin. It has two parts, hemo and globin. Globin is actually amino acids. So globin will form amino acids, and these amino acids can be utilized later to form again hemoglobin. So for the time being we will forget about the globin part. We will go to heme part. From this hemoglobin part, one molecule will be formed due to some enzymatic reaction. That substance is called biliverdin. Biliverdin. Verdin means green in color. So this biliverdin is slightly greenish in color. That is why it is called bilirubin. Bili because it is noticed in the bile, so it is biliverdin. Verdin means slight green in color. In the next step, it will be converted to bilirubin. Bilirubin. Rubin means little reddish yellow. That is why it is called bilirubin. So this one was green and now this is slightly reddish yellow. That is why if bilirubin accumulates in the body, the skin, the sclera and certain other parts will become yellowish in color because bilirubin is slightly an yellow pigment. Another point we have to keep in mind that this bilirubin which is formed is known as unconjugated bilirubin. So this is specially unconjugated bilirubin. Unconjugated bilirubin. This unconjugated bilirubin is a very toxic, very dangerous molecule. So by all means it has to be excreted from the body, bilirubin. In a day, how much bilirubin is produced in a body, in a healthy body? Normally around 300 milligram per day. Approximately 300 milligram per day is produced in the healthy body. Because whenever RBC dies, hemoglobin will come out and eventually unconjugated bilirubin will be produced, approximately 300 milligram per day in a healthy human body. As you all know, the life expectancy of this erythrocyte is 120 days. And sometimes in the infant's blood or in the fetal blood, this will be something like 80 to 90 days. Little earlier this will be destroyed due to various reasons. Anyway, our starting point is the death of RBC. Hemoglobin will come out. Globin part will go to amino. It will be formed to various amino acids. Heme part, we will get first biliverdin. From that, second step, unconjugated bilirubin. And this is the quantity of bilirubin produced in a healthy body. Now, as a normal procedure, this unconjugated bilirubin which is circulating in the blood will be taken to the liver. So this will go to the, suppose this is the liver. So this unconjugated bilirubin will be taken to the liver with the help of some protein, that is special kind of protein, bilirubin binding protein. With the help of that bilirubin binding protein, this unconjugated bilirubin will be taken to the liver. And here there is a conjugation process going on. What do you mean by conjugation? Conjugation means to add glucuronic acid. Glucuronic acid. This glucuronic acid will be added to unconjugated bilirubin, which is brought to liver with the help of bilirubin binding protein. So when we add glucuronic acid with the help of some enzyme, this bilirubin will become conjugated bilirubin. So what is coming out now? Conjugated bilirubin. This is what is coming out from the liver. The unconjugated bilirubin, which is formed first time, is soluble only in fat or lipids. So this bilirubin, which is unconjugated, is a dangerous subject, molecule that will be soluble only in lipids. That means lipid soluble. But what is formed next? Conjugated bilirubin. Conjugated bilirubin is water soluble. Water soluble. So by adding glucuronic acid to bilirubin, this unconjugated bilirubin will become conjugated bilirubin, which is water soluble. As it is water soluble, it can be excreted through stool and urine. As it is water soluble, conjugated bilirubin can be excreted by stool or fecal matter and urine. This is the normal physiology of this bilirubin, how it is going out of our body. Here, why we need a phototherapy? We have to come back to phototherapy. Because the unconjugated bilirubin, which is circulating in the blood and which was brought to liver for conjugation, is a complicated process, and our fetus liver, the liver of the infant, is not capable of doing full conjugation work because the liver is only in a developing stage. So the conjugation cannot be done fully. That is why this jaundice is being affected to the child. So as you all know, this unconjugated bilirubin, which is unconjugated bilirubin, is, as I told you, is a very poisonous, toxic molecule. If this unconjugated bilirubin goes to our brain, it is very detrimental to the neuron cells. It will go to the basal ganglia and cerebellar area and make problems. Some sensory nerve problem, hearing problem, then even it will affect the teeth. So, and the mental retardation will also happen to the baby. So, as early as possible, unconjugated bilirubin should be expelled from the body. The normal procedure is through the liver, because the liver will conjugate it, so it is easy. It is water soluble, it will go through the stool and urine. Suppose there is much quantity of unconjugated bilirubin circulating in the body of the fetus, what we will do? We will go for phototherapy. Here I have to explain the basics of phototherapy. What is phototherapy? We have to go to our electromagnetic spectrum. In the electromagnetic spectrum, we know that the visible light, our Vibgyor, 1, 2, 3, 4, 5, our orange and red. Our Vibgyor is lying on the electromagnetic spectrum between around 380 nanometer to 780 nanometer wavelength. So Vibgyor, our visible area, is between 380 and 780 nanometer wavelength. This you might have studied in your earlier classes. Out of this 380, between 380 and 780, there is an area covering the blue light and little green light. That area is around 430 to 490 nanometer. This area between 430 and 490 nanometer wavelength. This is the actual area or the band which is used for phototherapy. The maximum comes in 460. That is the maximum. Here the light will fall on the baby. Baby is laid in the incubator. Suppose the baby is here. This light of wavelength between 430 and 490, mostly blue light, that will fall on this baby. There are various commercial equipments to produce this blue light, which will fall on the baby. So what will happen if the blue light falls on the baby? Here we know in the body of the baby, unconjugated bilirubin is circulating. So when this blue light falls on the baby, the photons of this band, it will convert this unconjugated bilirubin, it will convert unconjugated bilirubin to another molecule known as lumirubin. So unconjugated bilirubin will be converted to lumirubin with the help of this blue light produced from suitable lamps. That is what is happening here. And this lumirubin is water soluble. That is the main point. This is water soluble and it can go out of our body through urine and fecal matter. This is the way our unconjugated bilirubin is converted to lumirubin. Actually, this lumirubin is an isomer of this bilirubin. There are configurational isomers, structural isomers, and also a photooxidation will happen. But eventually we will get lumirubin due to this photochemical reaction which is going on the blood of the baby by applying this light of particular wavelength between 430 and 490. The maximum is at 460 range. So just remember, we are utilizing the light of wavelength between 430 and 490. If you draw a graph, it will be something like this. So the maximum is in this area. Just remember, only this blue light can produce this particular wavelength, which is useful for the conversion of unconjugated bilirubin to lumirubin, which is soluble in water, and it will go out of the body through our urine and fecal matter. This is the 460 range, that is the maximum. This range is useful for our purpose. Long back, this baby was shown on the sunlight, and sunlight will help to produce this wavelength light, and this yellow color will be diminished. But under the direct sun it is little dangerous, because here comes our ultraviolet rays like A, B and C. These ultraviolet rays, of course, as you know, it is dangerous for the skin. So instead of keeping the baby under the direct sunlight, you can keep the baby near the window. So we can avoid direct sunlight, but we will get some effect of the sunlight. We have to avoid ultraviolet, also infrared. Both these bands should be avoided. And there are certain specifications. Number one, this baby should be kept at 45 centimeters from the lamp. So this height between the baby and the lamp source should be around 45 centimeters. Because if it is closer, there may be chance for baby getting a burn. If it is higher, we will not get enough intensity. So certain points. Number one, it is 45 centimeters. Number two, the irradiance, should be 430 microwatt per centimeter square per nanometer. That should be the irradiance. Irradiance means what? Irradiance means the intensity of light. That is how many photons are falling in 1 centimeter square in this particular wavelength. How much is the energy in watts? It should be around or approximately 30 microwatt per centimeter square per nanometer. That is the usual practice. And also, when this baby is laid here, the baby's eye should be masked in order to avoid any injury to the retina. And also the genital parts should also be masked with some diaper. So eye and the genitals should be masked. And another point is we have to check the temperature and the irradiance once in every hour or as frequently as required. And after 2 hours or so, the baby can be given breast milk or some other food. Then again, this should be continued for this practice should be continued for 2-3 days sometimes, depending upon the severity of the jaundice. This light can be normally it is of 4 types. That is, number 1, blue fluorescent lamp. Like our tube light or CFL. This should be blue color. Also, it is nowadays in practice halogen lamps. This is also used. Also, number 3, you can use this gallium nitride LED with gallium nitride. That is also in vogue in practice. Then there is a new development that we can use Billy blanket. It is known as Billy blanket. Billy blanket, how it works? It's a small piece of cloth which will be rounded with fiber optics, and from a nearby machine fiber optics will be coming to this blanket, and this baby will be covered with this blanket. That is what is called Billy blanket. That also can be utilized. Now I want to give you some idea about the measurement of bilirubin. When a baby can be subjected to phototherapy. As you all know, the normal total bilirubin is from 0.2 to 1.2 milligram per deciliter. 0.2 to 1.2 milligram per deciliter. That is the total bilirubin. Here in our blood, or the blood of the fetus or blood of any person, both conjugated and unconjugated bilirubins are circulating. So the unconjugated bilirubin is normally from 0.1 to 0.8 milligram per deciliter. And conjugated bilirubin is 0.1 to 0.4 milligram per deciliter. We will get total bilirubin when we add unconjugated bilirubin and conjugated bilirubin. So unconjugated bilirubin plus conjugated bilirubin will be total bilirubin in the body. So all these three test results we have to take first of all before we start any treatment. That is the first thing. Now, in an adult or in a healthy baby, the total bilirubin should be 0.2 to 1.2. Sometimes some people take it 1.5, 1.7 like that. But this is the ideal range. And we have to think about the treatment. Treatment should be started, or we have to think about the treatment. If in a healthy person, that means I will just write in an adult. If bilirubin is more than 2 milligram per deciliter, we have to think about some treatment for jaundice. That means in an adult, it should be less than 2 milligram always. In a newborn, bilirubin, if bilirubin is more than 5 milligram per deciliter, we have to think about the treatment. So just keep these two values always in the memory. For a healthy man or an adult, if the bilirubin is more than 2 milligram per deciliter, we have to think about some treatment for him. Also, in a newborn baby, if it is more than 5 milligram per deciliter, we have to go for phototherapy or something like that. These are the two ranges that you have to keep in mind. So, way to find out whether a phototherapy is needed or not for a baby is by the phototherapy chart. There will be a chart like that. Here it will be 24 hour, 48 hour, 72 hour, and 5 milligram per deciliter, 10, 15, it is written like that, a chart. Here you will see 3 charts like that, another one like that, another firm line. So this is the age of the newborn, that is in hours. So if the baby is 48 hours age, that is 48 hours after birth, if the bilirubin range is, say, somewhere here, we have to decide whether this baby needs a phototherapy treatment. So this is using that particular chart. This is a low risk curve. This is moderate risk, and this is high risk. These are the 3 curves. Using this chart, we can find out whether the baby needs treatment or not. There is another thumb rule, an easy method to find out whether a baby needs treatment or phototherapy treatment or not. That is, we have to consider a baby of 1 kilogram weight, at the time of birth 1 kilogram weight, and if the jaundice or the bilirubin measures 5 milligram per deciliter, this baby needs treatment, phototherapy. 1 kilogram, 5 milligram per deciliter. And it goes in multiples of this 5 milligram, every corresponding kilogram. So if this baby is 2 kilogram weight, and we can go up to 10 mg per deciliter. If he is, say, 3 kilogram, it is 15 milligram per deciliter. So this is a thumb rule by which we can see whether a particular neonate needs a phototherapy treatment or not for the jaundice. That is another point. Now I want to tell you another interesting fact. In a baby's, I'm just drawing a Suppose this is my baby. Here the most interesting fact is this jaundice is appearing in the baby in the cephaloccaudal flow, that is from head to toe. So this head, if this is yellow color, head and neck, this will be first range, that is 6 milligram per deciliter, head and neck. The jaundice will appear first in the baby. In which portion? It is head and neck. This portion. Then comes the chest. This is the second portion where this blue color will appear. When this comes to the chest, around 9 milligram per deciliter on this area, that means this is slightly progressing. Then the third range is this abdomen portion and thigh. This is the third portion where the jaundice will appear as per the severity. So the severity is coming, or the flow is from cephalic area to caudal area, that is from head to toe. And here in the leg, it is area number 4. In area number 3, that is stomach, abdomen and thigh, it will be 12 milligram per deciliter. Also, this area of the leg, it will be 15 milligram per deciliter. And the sole is more than 18 milligram. Similarly, this hand is also 3rd degree. And this palm is this is 4th degree, and his palm is 5th degree. So palm and sole are 5th degree. So if with a bilirubin meter you can measure the quantity of bilirubin in a child. If you measure his head and neck, and if you get 6 millimeters, 6 milligram per deciliter. You can see if you measure 6 milligram per deciliter, you can see it has affected only the leg and the head and the neck. And if it is coming down in the chest area, you will get 9 milligram per deciliter. The third area is the stomach and thigh. It will be 12 milligram per deciliter. So you can find out whether he needs a treatment or not. If you measure with the equipment in the sole, you will see if it is more than 18, definitely he needs a treatment. So the flow of bilirubin is from head to toe. That is why it is called cephalcaudal flow, from head to toe. So for the jaundice man, first it will come to the head and then chest, then stomach and thigh, then leg and then sole. Accordingly, this is graded. From this also you can find out the child needs a treatment or not. Similarly, another point I want to mention here, the bilirubin the total bilirubin which is coming from the erythrocyte or from the RBC per day, I have told you this is somewhat 300 milligram per day. Out of this, 80% from our RBC and 20% from other sources also. Bilirubin is formed not only from the destruction of RBC, it is also coming from what we call myoglobin in the muscle. Also another molecule, cytochrome. From these places also this bilirubin will come out around 20%. But 80% is from the destruction of the RBC. And when we talk about jaundice, we have to see whether it is physiological or pathological. What do you mean by physiological and pathological? Physiological means the normal way of forming the bilirubin. which is not harmful. This kind of jaundice you can observe in a baby 1 or 2 days after the birth. 1 to say 3 days after the birth. If you find jaundice after 1 to 3 days, you can call it as a physiological jaundice. Normally no treatment is required. It will disappear within a week or so. That is number 1, physiological jaundice. Number 2, pathological jaundice. This is physiological, normal way of forming the bilirubin, and this physiological jaundice, why it is coming, I will explain again. You know, in the fetus, this unconjugated bilirubin will be converted to conjugated bilirubin with the help of placenta. So placenta is, suppose this is the placenta. This placenta is helping the fetus to convert unconjugated bilirubin to conjugated bilirubin. But after birth, there is no placenta. Then who will take care of this job? This will be taken care by the liver. So, liver is supposed to do this job. But as you know, this liver is only under growth, or it is not a matured, well efficient liver. So it will take little time for this transition of this duty to be taken over by the liver. This transition period is there. That may be 1 or 2 weeks after delivery. By the time liver will be in full swing to take over the job. So that is why it is appearing after 1 to 2 days or 1 to 3 days after the birth. That is physiological. Doesn't require any treatment, it will disappear by itself. So that is the physiological jaundice. When we come to the pathological jaundice, this will appear immediately after birth. Maybe within 1 hour, 2 hours, 10 hours. It will appear within 24 hours, starting from first hour, 3rd hour, 4th hour, like that. It will appear within 24 hours. That means it is a pathological jaundice. That means some pathology, some problem is there when the fetus was in the uterus. That can be, number one, some liver problem, or ABO blood group incompatibility, or RH, rhesus factor, RH incompatibility. Especially when the mother is RH negative. This ABO incompatibility, RH incompatibility has already been explained in the previous videos. You can watch those videos. So these are the points. Another point I want to mention is regarding Brown's syndrome. This can be considered as a side effect of phototherapy. When we do phototherapy, sometimes you can see a brownish black color on the skin of the child. That is very rare, but in certain cases it will come like a side effect of the phototherapy. And nothing to worry, this will disappear within 2-3 days. This is what is called Brown syndrome. It could be due to the accumulation of porphyrin under the skin. Nothing to worry, it will go by itself. So these are some of the points that I have to tell you regarding this phototherapy. Phototherapy is not only done in newborn children. Phototherapy can be used by dermatologists to cure dermatitis, eczema, psoriasis. This kind of skin diseases can be cured by light therapy or phototherapy. This is the new development. And some psychiatrists claim that some psychological problems can also be cured by phototherapy. That is all under investigation, and we have to wait till we get a fully established results for that. So that's all I can tell you about the phototherapy. Thank you very much.